In the broad sense of classification, machine learning is practiced and distributed over two types. There is supervised, there is unsupervised. The difference being, in supervised, you know both the inputs and the outputs, but in each epoch, you find a way to get nearer to the outputs provided an input. One of the examples of supervised learning is face identification. There are multiple algorithms which can detect and identify a face. But in today's video, we shall be doing something slightly different. Instead of identifying the faces, we shall be classifying them as human faces. Cascading are components which are popping up from deep neural network concepts. They use HAR artifacts to identify images as human faces, and this is accomplished using overlaying several filters of different scale to an image recursively. The calculations are performed on adjacent rectangular regions which are specific locations in a detection window. The calculation involves summing the pixels of intensities at each region and calculating the difference between the sum, which are then cascaded over multiple filters to get a positive and a negative rate of classification, hence its name. Let's get on with the code, shall we? So let's start by importing the opencv library, which is import cv2. If you don't have opencv installed on your computer, you can go to your terminal and start typing pip install opencv-python. I misspelled Python, it's Python. My requirements are already satisfied. If you have older version or if you haven't installed it before, you can use the command. Next, let's start capturing the image on our web camera by of opencv library, which is cv2.video capture. Video capture accepts parameter. 0 will state that it is capturing from the default device, default video capture. If you have multiple cameras on your computer, you can give 1, which states it is capturing from the USB serial device. Next, we'll start defining the screen width and the screen height, which will make a lot of sense later part of this video. For now, we will give it as 640 by 420. Next, we shall define the classifier, the cascade classifier for the face first, which is like face classifier, which is face cascade equals cv2.cascade classifier, which will be taking cv2.data of HAR classifier, which is basically a path for the HAR cascade classifier. I will have this code linked down below so that it will be hassle-free for you guys if you want to play around with this code. You don't have to have the XML file downloaded on your system. It will directly take from the internet the latest and the greatest file and then rock you with the cascade classifier for both your face and your eyes. The next part, we will have to loop till infinity and read the data from the video capture, which can be done by using read, which is a function of capture. It will give success and the image itself. We don't want to use success anywhere, so we'll just ignore that. Next, we will have to create a grayscale image for the image which we have captured, because that decreases the dimensions of the video and the image significantly. This reduction will cost us a lot of time and space if we would do that in the color space, which is RGB. And we'll be converting it to a BGR to gray converter, which is cv2's conversion algorithm. Notice it's not RGB but BGR, so everywhere it's BGR, not RGB. Next, we'll start detecting the faces by using the cascade classifier we defined earlier. We can detect multiple faces with the face cascade function, detect multi-scale. It accepts the image. We will give the grayscale image, which we just converted. the scale factor, and the nearest neighbors, which are 1.3 and 5 respectively here. You can play around with those settings. So next, let's have a bounding rectangle over the faces and the eyes which is being captured. So the faces, whatever is produced, will produce 4 coordinate sets, which are 4 different integers. The 4 corners of what the algorithm thinks is a face, which are point x, point y, and the length of the other 2 points from this point, which is length and breadth respectively. We can draw a box on the face by doing the opencv library's rectangle function, which will accept an image. Here we know that the grayscale image and the color image are basically the same, and hence we can mix and match the two, because quote unquote we haven't changed any configurations like the pixel density or the cropping, brightness, contrast, etc. The rectangle function will accept 2 parameters, the diagonal points, basically the left diagonals and the right diagonals. So the left diagonals is the point xy, and for the xy, if we add the height and the width, it will be the right diagonal. The rectangle also accepts a color and thickness, which is again not RGB but BGR, and we can specify them. Now before we run this code, we will have to conclude the code with a few lines which will tell opencv that the image has to be shown flushed, without which the image will not be shown, or it will just throw you some errors. So we have to do opencv2 dot I am sure with a window and the image you want to display. It will also expect you to have a way to close the window, which is by saying if the keyboard click is Q, then break out of this while true loop and flush the capture, which can be done by cap.release, and we can also destroy the window by providing the same name which we had given during the I am sure. So now if I run this code, theoretically he should show me my face and recognize it. Well, hello there. Hi. It is not quite good enough in recognizing my face. That is because of the artifacts on my spectacles. If I remove my spectacles, it should be pretty strong in recognizing my face, and however I move, yes, it is good. It is pretty good. The reason why it won't recognize my face with my spectacles on is because it's looking for characteristic features like eyebrows. For example, if I close my eyebrows, it is clearly cannot recognize my face at all. Even my eyes, it's struggling again. But if it has all the features which it's looking for, it is pretty strong in recognizing faces. Moving on. Oh, we are not done yet. We will have to actuate a servo on the feedback, which is basically the output of this code. So we have the coordinates of what the algorithm thinks is a face. We will make it more precise with the eyes. So similarly, a for loop with the eyes and the rectangle on it. After that is done, we will have which is the average point, which signifies the midpoint of the square where the face is located. To do that, we will have a point called average x and an average y. Average x is the average x point, mid x point. The average y is the mid y point. So if you think about it, the average x is 2 times the x added the width, and the average y is 2 times the y added the height. That will form the midpoint. Next, we will have to have a reference point in the window which we are taking all these references from, with reference to which this average x and average y will be calculated. We will have the first point height, because it's a square again here, and the first point width, which is again the second point height and the second point width, which are the diagonal points of the square. They are the functions of the screen width and the screen height, which we had considered before. For simplicity, I'll be considering 1/4 and 3/4 of the screen. Next, we will draw a rectangle for this reference point we just created. So we will draw the rectangle on the image, which is the output image which we are considering, which is in between the point 1 and point 1h and point 1w as the left diagonal point, and the right diagonal point as usual will be the point 2h and the point 2w. So we will have a color to it and give it a thickness. The CV2 rectangle function will only take in integers. We will make sure all these points which are being used as a part of rectangle are integers. Next, we will find if the average x is less than the average 0.1 height. If so, we will have to actuate the servo to move right, and we'll also put in a text to debug.
Debug, he says. It is actually meant to look fancier. Right, guys?
So we'll have the text put up at the XY coordinate. I have a copy of font in my clipboard. I'll be just pasting that. If that is not the case, if it is not less than, if it is greater than, we'll have to move left. Actually, if you think about it, it does not make sense to have it as if-else-if ladder, because it can be move up and move left. This has to be if ladder, not else if ladder. There is a necessity of it to check all the conditions before it makes a prediction. So we cannot have it in else if ladder, it has to be in if ladder. If the average y is less than the 0.1 width, it has to move down. If it is greater than the average 0.2 width, it should move up. some small corrections. I had mistaken the point 1 and point 2 in the rectangle, the reference rectangle of the window. And shiver me timbers, we have to divide 2 in order to get the average of the point, the x and y coordinate in the faces. And eyes both. Now if we run this command, we should technically have image recognizing my face and eyes. Had the move down text outside the window, so I had to change that too. Next up, we need a common communication medium between this Python code and the Arduino itself. So the easiest way of doing that would be to have a serial port connecting both of them. So we'll be using something called as PySerial. Pip install PySerial, by the way. Let's create an object called add for the serial communication. Serial.serial, one with the small s, the other with the capital. This function accepts 2 arguments, the first being the port and the second being the baud rate. Because we'll be working with strings in communication, we will have the baud rate set to 9600, and the COM port is the same COM port with which the Arduino is connected to your computer. Again, even this code has to run infinitely, so we will start with while true. Initialize a variable called command which takes in the input, which is the servo input in our case. In real sense, this command will be taking input from the image classification.py file. Then it should write back the value to the serial port, which can be done by using add.write function of the serial library, which will accept a string command. Editor here, it requires byte, not string. Then we will read back the serial port as a confirmation of the handshake that the Arduino would have made. Stay tuned for the next video. Believe it or not, there are still a lot of work to do. We will have to configure these 2 functions as 2 different threads, run them parallelly, and draw conclusions whether the auto tracking camera systems are really any good.